All right. Hello, everyone.
Hello.
How many of you are just about dying to stay here for another 2 hours? I can oblige. Just letting you know. Thank you very, very much for coming here and listening to me. I have some good news and some bad news for you. The good news is I really love Flutter, so I kind of was like, I want to go talk about it. The bad news is I love Flutter because I started looking at it over the holidays, and I'm like, why are we not doing more of this? So you're going to have a mixed experience. But at the end of the day, I had a very, very simple goal with this talk. And it was that kind of to create awareness about this technology and get you excited enough to go and explore this a little bit more on your own. So just a quick show of hands before I start. How many of you here are web developers? Oh, OK. How many of you are mobile? Android? Mobile iOS? OK, cool. Not bad. Anyone use Flutter? Ask him all the questions.
No, I'm going on the code lab. Please don't.
No, we're not going to get the code lab done. I'm literally going to try to time myself. The biggest problem I have is I talk a lot. So we're going to try to get through this. So anyway, welcome. And today we want to talk about Flutter. So the goal for me is to kind of get you a sense of what Flutter is, how you can use it, and then give you enough pointers, resources, so you can go off and learn about it on your own. So let's kind of start with the big picture, right? What exactly is Flutter? So at a very high level, this is kind of like the Uber one-liner definition. It's an open source SDK from Google that helps you build performant and customizable UI for modern mobile platforms like Android and iOS. But the most important thing that people will kind of emphasize is you build it with one code base, right? That means you as a developer have one source and you get two apps out of it. Now, a couple of things I want to point out here. First is it's currently in alpha. And that, if you're like me and you've been burnt by the v1.0 lower versions, is a little scary. But the reality is it's actually being used in production at Google. When they talk about it being alpha, it just means that there are a lot more features they want to implement that they haven't had time to get around to. But what exists has been battle tested. So if you go and try it out, it should be pretty stable. The second thing is, and I know you can't even read that, but who's heard of Google's Fuchsia? Right? So that's an Ars Technica article that's linked over there. If you go check it out, turns out that they talk about Flutter being the SDK that was used to build the mobile UI for Fuchsia. And if you actually go look at the Gitter chat rooms and look at any of their documentations, you find references to it. So great. We know that's the marketing pitch, but who is this actually for? And the big answer was, it's for everyone. Oh yes, wonderful. What does that actually mean? So what happens is when Google was doing this, they looked at who are the stakeholders when you build apps, right? How many of you are independent developers by any chance? Okay, how many of you work for large companies? I'm guessing everyone else. So you know, right? If you're in a large company, you know you have multiple stakeholders. You've got designers, you've got developers. You're going to have the managers who are basically about like, hey, what are the things you're going to do and when? You have open source contributors who build things that other people use. And finally, if you're an independent developer, you also have people who are interested in rapid prototyping. How quickly can I take an idea to product, right? And when they talked to all these stakeholders, the thing they came up with, there has to be a way where we can build a solution that helps all of them with their requirements. The bottom line, though, is most of us have framework fatigue. How many of you were dying in 2018 to learn one more framework? Right? Not me, but I kind of have come to the stage where I have these two kind of like sides, right? One is the pessimistic side, which says ignorance is bliss. Not another framework's not going to work, let's not bother. But the other side is, instead of thinking about it, look at it pragmatically and say, what about this do you learn that's really interesting and how can we use it for various things? So for today, I want you to just kind of put your pragmatic hat on and think about what are the ideas in this that are useful and how could you leverage this when and if you get an opportunity to do so. A little bit about me. I'm not even going to read this. I've been doing software for like over 2 decades. I've been in industry, I've been in academia, I've been an independent, I've been all over the place. So I really don't want to go into it. But at a very high level, I do 2 things. I like to build solutions for small startups and local businesses, and I really look at it from a very pragmatic perspective. For a given time, for a given cost, what's the quickest thing I can deliver, right? And the other side of me is I build inclusive communities. I run Google Developer Group in New York City and Google Developer Group in Hudson Valley. If any of you are in that area, come say hi. And in that case, my goal really is on creating technology awareness, right? The more we know, the more we can actually use it. So when I put my kind of developer hat on, people kind of come to me and say, hey, can you do something for me? What do they want? It turns out that they actually want one of two things. Either they come in with an idea, and this is the startup person, right? They're like, hey, I have this idea, and I need you to build me an app. And I want that app to be a functional prototype. It doesn't have to be robust. It doesn't have to kind of like be awesome. It has to be functional, but I want it fast, right? And those are the people who are really kind of don't know anything about technology. They just want something they can take to a VC for funding or to a user group for testing. The other side is people who already have products in the marketplace. And their requirement is different. They're like, hey, I've been building this with legacy solutions. I see all this new hotness. How do I migrate, right? How do I evolve my solution in a way that I can kind of iteratively move towards something better without destroying what I have? And it turns out that regardless of which side you come from, the requirements are the same. People want componentized architectures. That means you want to be able to reuse before you build. You want to be able to mix and match to get to where you want to go as fast as possible, and then customize. And when it comes to the customization, they want customizable user experiences. What that means is that, ooh, okay. What happened here? Auto power off engaged. Which cable? I don't think so. This thing just said, you.
Just gonna.
Why is auto power off engaged?
If it stops detecting your connection, it'll kick in. Usually.
I think he was taping something, and I think that's probably messed up. Oh, wonderful. Did the power in the room go off too? Is there something, like, were the lights on and they went off?
The projectors are on.
The projectors are on, yeah.
Yeah, that power strip down there looks good.
Yeah. All right. We're going to try it one last time.
Server back there.
It's giving me ominous things about remaining time 13 seconds. You cannot present locally when a VC meeting is in progress, okay? Connect to the VGA cable. Why is it on VGA? Oh, okay, something happened. Whose is
These
that?
are positive things. Right?
No, it's gone to something else. It's not connected to
Probably Chromecast or something.
mine, yeah. No, it's not mine at all. It's connecting to a different machine. So you see, I'm like, there is no way I would have those photos on my screen. All right. Okay. We do this again. I literally put a slide that said custom is hard and cross-platform is costly and blew everything
There we go.
up.
Okay.
Okay,
Oh
good.
my God.
Wow, okay, everybody just stay still, I hope. All right, that messed up my time, but that's fine. So when you kind of look at all the Flutter talks that are there, the bottom line for Flutter was this recognition that doing anything custom is hard. When you want to build custom layers for animation, for transitions, anything, right, it's hard. But if you think it's hard enough to do that in mobile, it's doubly hard when you have to make sure that the solution works for every platform, right? So doing it for iOS and mobile means you need two teams. Both teams would need to have experts who know how to build this and design with the respective platforms, and they would need to know all the quirks of their respective kind of deployment chains, right? So cross-platform is costly. How do you solve that? And this is what it was like. Flutter was like, I got this, right? This is the solution we're going to try to. I don't even drink. Don't even ask me why this is a joke, but that's fine. And that literally, if you take one thing away from this talk, it's this, that the focus of Flutter is that you can build things that one code base, customizable everywhere. Every single layer of Flutter's architecture allows you to customize it from the foundation onwards to rendering, painting, widgets, and beyond. So quick demo. What we're going to try to do, hopefully if this all works, is I'm actually going to pull up, if you have, can you see this okay? Okay. I don't know if I can, all right. So if you actually, we're going to minimize this. If you go to the Play Store or if you go to the App Store, you can actually download and install this app. This is the Flutter gallery. It's a native app for those platforms, but what it does is it shows you all the widgets that are available on the Flutter system, so you kind of get a sense of the capabilities. So I want to really quickly kind of showcase a few things. First is you'll see that they have a ton of stuff, right? Here's an example of a complete full-featured standard app that you'll see for almost pretty much all these card-based sites that you get. There's a sample for that you can pick off and really quickly build. List-based UIs, not a problem. And I want to show you something in just a second. But the third thing we'll look at is things like animations, right? So when you look at Android or iOS, if you've built stuff in there, you know that you've got standard ways to do specific things, right? User experiences. What if you wanted to come up with a new way? What if you wanted to have swirling animations? What if you wanted to have a gesture that actually composed three things together and did something, right? So if you look at these kind of transitions that you see here, they're all Flutters, right? They're not necessarily kind of built from one platform or the other. And more importantly, I'll show you a second thing. If you look in here, in the gallery app, I hugely suggest you go play with it. You'll see that they actually have Mountain View and Cupertino. And what that means is like from the same code base, the same app, they have these two high-level themes, if you will, that reflect the look and feel of those two platform requirements, right? So if I were to switch this to Mountain View, suddenly I'm going to have things that behave like it was on an Android phone. So for instance, if I go to the address book on an Android phone, right, when you scroll this, you should see this little, you can't see it, but you see that little thing bump come up. Whereas when you see it on iOS, the behavior is different. You'll see the top will bump, right? You see it bounces back. So effectively, you were able to get custom-looking interactions, right? Transitions, animations, with the same code base that literally reflect what it looks like for the native platform, but they weren't built with the native platform widgets, right? So this is actually one of the biggest takeaway from this. Now, from the perspective of people who want to use this in the real world, this is compelling because how many of you kind of like played Monument Valley, for instance, right? You know, there is this wonderful thing. This is what mobile is as opposed to web, right? You go in there and it feels rich, it feels immersive, it feels like magical. You can't do that if you're just using OEM widgets and like hammering them together, right? There's nothing, you need people to think this. So the question is, how do I get that kind of like look and feel with existing things? And that's what Flutter is trying to get at. So let's go back to the slides. And by the way, Wiley is my best demo god, right? Like means that everything I do is going to fail sometime. It's just got to be prepared. So the thing that you want to think about when you think about Flutter is it's not only open source, so you can customize everything, but that customization can actually be performant. In addition to performance, we're also going to talk about reactive in just a minute. So at a high level, we know it's open source. We know with the unified code base you get two apps. So now we want to dive in, and I want to dive into two parts. First is the performance and the architecture. How do they make it happen so fast? It's 60 frames a second for all their animations. How do they make it work so well? And what's this architecture that allows me to customize everything? Second part, we're going to look at the SDK and tools. How do you actually get started working with Flutter? And this, how many of you here are Unix fans? How many of you like command line tools versus IDEs? Come on. How many of you like command line tools? Everybody. IDEs suck. But anyway, you actually have a really, really powerful command line utility and IDE support, which makes it really nice. So we're going to look at these two. First, we'll start with the fast and flexible. Fast and flexible. 60 frames a second for all their animations, and a layered architecture that lets you customize any layer. How do they do that? So it started with, and this is a little bit of history. I hugely, hugely recommend you watch the keynote at the Dart Summit last year on Flutter. That gives you a really a good sense of how they designed it. But what they started off with was a very simple thing. Mobile web, when you want to think cross-platform, when you want to think componentized, you know, I do it all the time when I have to build apps for customers. I'm like, you want the maximum reach, go mobile web first, right? You don't have to install it on anything. It's there, you put it on there, web will work. And web fails when the native APIs that we want access to are not working very well. With progressive web apps, we're getting closer and closer, but that's the thing, right? Mobile web, I've always been like, yes, the greatest thing since sliced bread. but it's not performant. Mobile web APIs, like the web views are not necessarily the best. So what they kind of looked at was, can we take the lessons we've learned from web views? Can we take the good stuff in there and figure out how to shrink it to work on mobile, but do it not by like retrofitting, not by taking it and stuffing it into that platform, but really thinking, how do we take the concepts and tailor it to work with the mobile architecture the way it was intended? That was their big goal. Casper Lund's talk is amazing. You should go check it out. And the way it kind of split up is these two things. One is the performant part. The other is the reactive part. Performance was, they realized, they kind of looked at all the web apps and said, web layouts are slow. They're janky. There's a huge amount of stuff that goes in. And a lot of us, how many of you kind of love the web the way it is right now? We carry oh, come on. We carry a lot of legacy stuff from years of web development that we don't need for modern web apps, but we're carrying it because we have to, right? So web layouts are slow because they kind of have these various old things they carry along. We're getting to better things, but it's still there. Web views today are living off of those problems. Second, web apps were meant to support really complex uses, right? You think you're going to have a giant screen. You're kind of expecting you'll do many things. But when you think of a mobile, there is a different mentality and mindset. You don't need complex use cases. Most things in mobile are very much about click, scroll, tap, right? So we need to rethink that. And third, web layouts use global rules, right? How many of you love CSS? I don't. I will just tell you right up, because it's ridiculously hard to figure out, who's cannibalizing who, and it's complicated. So performance-wise, we need to think about what we want to do with the good things in the web, but addressing the bad. Mobile users also expect, from a reactivity perspective, they expect richer user experiences, right? They want fast transitions and animations. So what do we need? First was the recognition that mobile layouts are actually simple. So one of the fundamental things in Flutter is everything is a widget, and they recognize that let's optimize for the most popular things people do. Text on scrolling, fixed rectangles, and some tables. But the most important thing is layouts are local. Like when you render something for mobile, you're really thinking about the small thing on the screen. You're not thinking about all the stuff that's outside of your view, right? And because of that, you're really trying to optimize the rendering for changes in state. So how do we do that? On the reactive side, how many of you are familiar with functional programming, reactive? How many of you know React, by the way? Okay, so you know that that's the new trend, right? How do you create architectures that propagate state? No longer pull, but push. Anything that happens, and there you need three things. You need push notifications so that state is propagated from wherever it happens to all relevant subscribers. You need sync mechanisms so that distributed data is kept in sync. And on the view side, you need auto refresh. You need some way for the mobile UI to automatically reload and re-render anytime there's a change in state associated with those models, right? Have you seen this by any chance? This is like hands down the one table that literally explains to you where Flutter fits in. So when they looked at this broad space, this is what you see today. If you're going to build anything for the mobile, you're on this side, right? You've got compile, you've got native Android or iOS apps, and they're right here. Most of them use MVC, MVVM architectures, right? You're pulling state, you're synchronizing it. Great. This is where we are. What they did with web, like, if you believe, hey, we need to bring web features into mobile, what they did was they kind of went down that direction initially, right? Titanium, PhoneGap, Cordova, you guys familiar with this? They took JavaScript, packaged it up, deployed on native, right? But what they did is there it was interpreted. The code was still being done in JavaScript. It had to cross over and make calls to the native layer. And we're going to talk about that in a minute. But that's what there was. React Native, on the other hand, both of those were using, pull architectures to some extent. React was the first to say, let's rethink that, what Cordova was doing with React Native, right? They're like, let's rethink this. There has to be a better way, right? We want it to actually be push-based. We want to have state that kind of changes and automatically refreshes. And that's where they were. But they're still interpreted because you still write your code in JavaScript and you have to cross that bridge. This is where Flutter fits in. The whole differentiation of Flutter in a nutshell is that they are a compiled solution that you're getting your final code directly in native ARM level performant executables, and they're actually born reactive by default. That little bridge thing there kind of will explain how this, or why that matters. The problem with React Native, and the first time I heard this talk on Flutter given by someone at GDG, I was like, wait, this is React Native, right? I'm just going to be writing my code, but it wasn't. Because with React Native, what happens is you're still writing all your code in the JavaScript realm over here. Your mobile app is talking to it, and every time you want to use any native UI, native widget, native event, whatever, you're going to have calls made that has to go over that bridge. Context switches are costly. The more you do them, the slower you get. And bridges have tolls. Performance-wise, when you think about reactive, if you have a ton of objects in your view, everyone changing, you're going to be crossing that bridge a lot, right? It's not really effective. So at this point, this was where, how can you make this reactive? And I'm going to try to speed through this so we can actually go to the point where we build this. But it's really cool to learn how they thought this through and unpacked it. So how many of you are familiar with this notion of a virtual DOM? OK, so I'm just going to give a quick kind of like high-level view of it. When you think about reactive frameworks on the web, and all of these kind of come from the Flutter site. You can go and check it out as well. The way it works is the screen that you have, the view, whatever you see on the screen, think of it as a document. It's DOM as a document object model, and that's literally what's kind of like being rendered on the screen by default on most web pages, right? Lots of little objects, all of them doing various things to kind of paint to the canvas, send events, etc. That's the real DOM. And for the longest time, we were living in DOM hell because we were trying to manage that and take on all the overheads of manipulating it. What React did was this notion of a framework where they created a virtual DOM in our application space. And the virtual DOM is like a copy of this, but you make your changes from the application into this. And what they do is they say, and this is very true, I'm sorry to say this, developers are dumb, we make dumb mistakes. So if you are not optimal, you do whatever you want to the virtual DOM. We will, when you're done with your changes, we will compare it to the physical DOM, get the diff, and we'll apply the diff to the actual physical DOM. So we're going to actually only propagate the minimum number of changes, not every single thing that you thought was relevant, right? And that was really their big, big win with virtual DOM. When you take this in React, this is React space, and go to React Native, the only thing that changed is instead of DOMs, you're talking widgets, right? Because now you have, they were like, hey, virtual DOM, virtual widget, same thing. We're going to have a fake version of this that's in the application space. You do all your stuff to it. We know how the platform level views work. We'll diff it, patch those, right? You don't have to worry about how to do it optimally because we'll make the smallest number of changes you need. You'll be good. So this is where they were, but you were still crossing the bridge. And I'm going to do a sleight of hand so you should pay attention to what went away. This is what Flutter is. So kind of, does that make sense? That render layers hopped over to this side of the screen, and everything else in the middle disappeared. And this is the power of Flutter. What it really is doing is saying, forget the platform widgets. Why are we trying to like work with these things and like, you know, try to manipulate them? Instead, they're talking to the canvas. We'll just talk directly to it. So we're rethinking how UI architecture should be. We have our own widgets, right? No longer OEM, all Flutter widgets. We know how to render directly to those elements. We cut out all the middlemen. And when you're done with this, you'll have a widget tree that you're going to talk to our layer. We're going to compile it. It's going to be ARM code, so it'll be super efficient. And how many of you know structural repainting? I don't know enough about it, so I don't want to sound particularly dumb, but I can try to explain what I think it is. Have you heard of structural repainting or bit blitz? Oh, yay, we can all be ignorant together. This is good. But basically, the idea there was that, and I could be wrong, but the way I think about it, it's like pixel level diffs, right? Instead of object level diffs, that you look instead and say, here is the canvas. It's composited with all of these various things. I know what's on the screen right now. According to what you're building, I know what you want to render. I'm literally going to do a diff at the screen pixel level. I'm literally going to patch that screen up. So it's super fast because it's not going through various levels of objects. It's literally going and painting and compositing that screen. So that's basically their primary driver for performance. So far, so good. It's kind of everyone got the big picture of why Flutter is more performant? Okay, one small goal achieved. So the second thing we want to talk about is, great, you sold me, this is so cool, and absolutely, I was suckered into reading tons of docs because it's sort of fun. But how do you actually implement this? This sounds like a lot of, hot air. The way to do this is layered architectures, and this is what Flutter's architecture looks like. And now I'm going to ask the question that's going to make you all hate me. How many of you know Dart? Okay, Dart, ever heard of Dart? Yes, okay, how many of you heard of Dart? Okay, so we're not altogether bad. Yes, I know, I'm like basically telling you 2 new technologies that Google makes that you should adopt tomorrow. Okay, whatever. But I actually had looked at Dart many years ago when it first came out, and I never went near it. For those of you who are unfamiliar with it, Dart was kind of their version of a better JavaScript, a stronger, more modern-looking JavaScript. It's got single inheritance. It's an object-oriented language. It tries to fix a lot of the issues like typing, type safety, and all that JavaScript had, right? But it never took off because, hey, JavaScript is JavaScript, right? Nobody wants to let it go. It's like your blanket from your teenage years, like, oh, whatever. But bottom line, though, is Dart has certain properties that make it super efficient for what we want to do. And I'm going to talk only about 2 of them, and then we're going to look at the architecture. The first is it's a tree-shaking compiler, which means that when you actually compile your code with Dart, it looks at what you're building, and it walks through and picks the minimum number of objects you actually need. It doesn't try to compile everything that you've got in your code. It takes the minimum number, so you get the most optimal executable that you need. The second side is this thing called the generational garbage collector. So when you're doing reactive UIs, you have to think that the view is getting repainted all the time. Every time it gets repainted, it's like you took all the objects that were managing it, you dumped them on the heap, and you instantiated new ones, right? That's a lot of thrashing. It's taking a lot of memory. Generational garbage collecting basically says, we'll give less priority to things that are new. Like, we'll quickly garbage collect things that were just created recently. So every refresh is very, very quickly swept up, and you're releasing the memory. Very, very efficient. So those are a couple of reasons why they said we should look at Dart. They initially didn't, apparently, but now they do. But I want to kind of like talk about a couple of things in this architecture, and then we'll kind of move on to the next phase. First, you'll see that there's a clear separation of concerns. There is a low-level engine, all C++ code, and then there is the framework. The low-level engine has got 3 components. There is Skia. How many of you are familiar with Skia? It's a 2D graphics engine that's used in Android. It's the graphics engine that's used in Android, also from Google. I believe also open source. That's the thing. Everything in this is open source. And their goal here is like, why reinvent the wheel? This is battle-tested stuff. Everything that you ever want to do with 2D graphics, that engine is popular. It's being used. Already does it for us. We will just kind of use that out of the box. So Skia is there. On the other side, the text engine comes from Chrome. So again, another battle-tested engine that can kind of do things like internationalization, text scrolling layouts, all that kind of stuff, right? It does that, takes care of text processing. And in between is Dart for everything else, notably widgets, right? So this is the bottom line engine. You don't touch this, but everything about this is fair game. Now, caveat, you can actually, if you want, go and hack this because it's all open source. I'm just saying, don't. Just think about there. All the layers above, all of those layers have components built with Dart. All of them are open source, which means you can go in and hack any layer you want, change anything you like. Second thing is that the layered architecture means each layer builds on the one below. So there's a foundational layer that talks to these low-level components. Animation, painting, and gestures have custom components layers that you can go and like switch out and extend, come up with your own gestures, come up with your own animations, make it available to everyone above you. And once you get past the rendering, I'm not even going to go into rendering. One day I'm going to do an entire talk on just rendering. That thing is like deep. But let's look at the widgets layer. Widgets is their standard widgets, right? Dart out of the box gives you a whole bunch of widgets. Think like these are not OEM widgets. These are Flutter widgets that have been crafted to be optimal for this architecture. They're over here, huge number of them. And above that, building on those are Material and Cupertino, which have picked these up and customized them to suit the behaviors on Apple and Android devices. Make sense? So this is the architecture. Every layer of this is hackable. Great, now we know how it works. How do we get started? So the beauty of Flutter is it is super easy to get started, and the tooling is magnificent. This is literally like the screenshot from their website, but all you have to do is go to their GitHub repo, download, install the repo, go find the bin directory, set it on your path, and now you've got all the executables, right? In addition, if you are hardcore, you can get away with just that and an ID and a text editor. Like hardcore people can pretty much do everything with just a command line interface. But for people like me who are a little bit less likely to go digging into everything, there is an IDE. And it's IntelliJ's. IntelliJ actually makes the Android Studio IDE. So when you actually install the you can use Android Studio itself and just install the Flutter plugin, or you can install IntelliJ IDE IDEA, which there's a community edition and an enterprise edition. That comes with the Flutter plugin by default. And the most awesome thing about this, and I told you before, CLI is always better than IDE, every single time, right? Because there's something really magical about quickly being able to see what's there. They have a really rich command line utility called Flutter that helps you get from your first setup all the way through run and deploy, literally from command line. And I just kind of highlighted 4 things that you need to know. The minute you install it, you're going to get access to these. Flutter Doctor, and I'll actually show you if I can. I don't know if you'll be able to see it, but you can try. By the way, did you know you could make your terminals have custom backgrounds so it actually has a Flutter? Nothing. Nothing. I got nothing better to do with my life. All right, so here's what Flutter Doctor does. When you do Flutter Doctor, once you finished actually installing it, what it does is it understands what operating system you're on. It goes through and it checks all the dependencies that you need for your distribution. And it literally tells you, install this package, install this package. It's really, really seamless. Within an hour, worst case, you'll have installed and downloaded and done everything, you're set up. As long as it comes off saying you're good to go, it means that not only are you set for building those apps, but you're also set for deploying it to both platforms, Android and iOS. You can see that it checks all the tool chains for you. So this is super, super useful. Then, second thing we're going to talk about is Flutter Format. All right, how many of you are very hard-nosed about how many tabs, how many spaces versus tabs, how many indentations, how many of you are like that? Those people drive me nuts, because when you're working in these big teams, it's the worst thing when someone goes and reformats all the code to suit theirs and then you have to figure it out. Flutter Format, Golang, all of these are now doing this thing where you can just have all the code formatted according to a standard guideline that they provide. Now, you can go ahead and change it for yourself later, but this is super useful in terms of if you're in a team having the same view of the code once people have made changes. It always looks the same. Also, if I have a time, we'll look through the IDE itself. It does some phenomenal stuff. It automatically puts comments telling you where big classes end and begin. It has command line completion, lots of other stuff. Flutter Run. Flutter Run is what you'll do to actually execute and launch your executable. And when you use Flutter Run, you're actually going to execute it in a particular environment. And we look at that in the next step. Flutter Upgrade, once you've got this distribution, Flutter Upgrade just lets you keep that distribution up to date. Flutter Upgrade command line, your Flutter is brought up to speed, done. This is what it looks like when you start create a new project on IntelliJ. We'll try to do it in a minute if we can. Create new project, you'll see you automatically see a Flutter plugin if you install the default. If not, you can install it in Android Studio. You'll get a similar look and feel. And at this point, you'll get to this where you've got a scaffolded app. You do a create project, say okay, it scaffolds out a project. And we're going to go look at that in a second. But if you want to use Flutter Run, which I showed you a minute ago as one of the command line utilities, you want to have some target that you can be sending that to for running, right? So you can actually do this either through the IDE, and we'll look at that in a second, or you can use command lines to start it up. Android will allow you to start an AVD from command line. iOS has an iOS simulator that you can start from command line. Once you've started them up, Flutter devices will tell you how many targets are available to you in your local environment. So it automatically tells me, hey, you've got one Android device, emulator, and one iPhone, right? So you can actually see this on mine. I've kept them open for the longest time. Here's my iPhone and here's my Android device. So it can see those. And once you've got them, you can pick the target that you want. So you can say Flutter Run -d and pick the actual named identity, or you can just say Flutter -d all, and it'll take the same code base and launch it simultaneously on both platforms, which is a great way for you to compare and contrast what it looks like, right? Okie dokie. All right, demo. So let's go try. If the demo got smile on us, we'll actually try to we'll try to build a whole thing from scratch. But because I have such little faith, I'll actually have a version that's been created before that we'll look at as well. Let me see how I'm doing. Do you want to just quickly see how you create one, or do you want me to look at the code for something that's already done?
I'd like to see how to create.
Okay. So Let's do that then. So this is, can you see this okay? I know the font's maybe a little small, but we'll try to get that in a second. So create new project, and it tells you Flutter SDK path. The one twist down the line you'll find out is Flutter by default will bring the Dart installation with it. So Dart is also installed without your knowledge. If you ever want to go down later and just do pure web apps, you can do it with Dart, and you can use the same distribution. But anyway, go in, you pick a project name. So let's do Windy City. And we're basically a new Flutter project that can crash and humiliate me. I love that. Okay, and something, right? So let's pick, okay. And at this point, it just has nothing. There are some constraints that will tell you that you can get to do on your own. We're going to hit finish, and in a couple of minutes, you can see it's creating the project. We'll move these emulators out of the way. All right. And my computer is a little older, so it's a little bit slower. It's actually much faster on the other one at home. All right. Don't try to migrate to Gradle. So we're going to do a couple of things just to show you some of the interesting features here. So this is your Flutter app that's scaffolded for you. When you open it, the interesting thing is you'll see that there's an Android directory and an iOS directory that's created for you. The code gets compiled and put into those for you. You're never going to actually mess with that much. The code that you're actually going to be looking at is in here. This is that single code base that's going to get compiled to both, and it's this is the app. And I want to show you like a little bit about widgets, and we'll come back and look at this. But for now, we'll look at two features. First is I want to be able to run this, and this is where let's pray it all works out. I'm going to say launch this, and I currently have, I had this other one from before, so let's wait and see. Takes a little while because it's really slow, but you can see that it's building it for Android. Once it's done, I can actually, if I want, go flip it and say open the iOS one and target that, but we'll stick to Android for now. My thing's really slow, but while it's going on, I'll tell you a couple of things that we're going to explore. First is you'll see that it'll build the whole thing, package it, and ship it, and run it, just like you would with Android Studio. But once it's done, we're going to look at two things. First, remember I was telling you about Reactive? So this is one of the best features of Flutter. It has hot reload. And hot reload means that while your app it has both just-in-time compilation and ahead-of-time compilation. While you're in debug mode, you can use just-in-time compilation, which means that if you make changes in your code, it'll actually compile and inject those changes into the active stateful runtime and update it. That means you can do things like, and we'll try it, this is the standard demo they do for all the Dart things, so that's what we're going to do. You can do things like change the color of the screen, and it will show up. It's still installed, right? And you'll see, like, in front of your eyes, it will, right? As opposed to when you had to do this for native, you had to actually go through the whole compilation process, push it to the device, rebuild it, takes a long time. Here it's called hot reload. And the second thing we're going to look at is a little bit of the look and feel of the app. So here, reactive. Can you see this? The counter is changing. So here, the stateful hot reload works as follows. Now let's say, this seems to be the most visible one, so that's what I'll do. Let's pick a color, we'll go for orange. When I save it, it says it's initializing hot reload. And without my doing anything, 4 seconds, it hot reloaded the app, right? You can see it changed the color of the screen, and I didn't actually go through a full-fledged application compile and push. So this is the value proposition to designer stakeholders in particular, because they can actually go and like fix things really quickly and in real time iteratively see what it looks like. So this is one of their big things. The second, and you can also do things like, let's say we're going to change, this is Flutter. I'm not going to go beyond that because hot reload, it changed the title, right? So I want to kind of go through what this app looks like, and then we'll go back to the slides and talk about the larger architecture. So the first thing is, if you're not familiar with Dart, this is written in Dart, right? But whether you come from Java or whether you come from JavaScript, it'll look like it's familiar. I bet you could look at this code and know what it's doing, right? So the two things you need to know, and right now I'm actually, if you're okay, I'm going to shut this down and open up the other app that I'd actually annotated because I wanted to terminate that. I wanted to actually pick up or highlight, remember to highlight specific things to you. Okay, so we'll scrunch this down again, and then we're going to talk about it. Actually, we'll be really fast because I know I'm running late. I warned you. Okay, the two things you want to know. Everything in the Flutter app is a widget. So at the very top level, the first thing you'll see is there's a void main. Immediately you start seeing something strange. You can mix classes and functions, like interactive in the same file, nothing happens, great. This main method is the entry point for your app. And you'll see that it has a run app. Run app expects to have a widget that's provided to it, which has to be your full bleed screen widget. That will be the root of your widget tree. That's all you need to know, right? And by default, what we've said is, hey, it should be this my app. Now, I'm going to kind of quickly look at this and switch to the slide so I can show you something more interesting, and then if we have time, we'll come back and read all of this. How does this work? Everything is a widget, but there are two types of widgets. There are stateless widgets and there are stateful widgets, right? So you can see that you're here extending a stateless widget. Here you're extending a stateful widget. And the stateful widget is associated with another component called state. Inside here, I'm going to show you one thing. It'll make sense in a second. Anytime you have a stateless widget, it'll have a build method. Build methods return widget instances, right? So every time you're building the tree, whatever your kind, like the top level widget will actually try to compose itself from other widgets. Each of those widgets that it stamps and instantiates, it's basically calling the build method saying, give me back a widget, puts it together, composes it, right? So stateless widgets have a build method. Stateful widgets, on the other hand, and let's see if there's one other thing. Okay, stateful widgets, on the other hand, have a slightly, oh, don't do breakpoints right now, dude. Okay, have a slightly different thing. First, they don't have a build method. They have a create state method, right? Just keep this in mind. This is the one thing you need to remember from this, okay? And second, they have these final attributes. And in fact, stateless can also have final. All you need to remember is that there are two kinds of triggers for reactivity, right? One is configuration information. The other is internal state. So in a stateful widget, this is saying, here is the internal state of this widget. This is saying that's the configuration information. And I'm going to switch to the slides, race through them, and then if we have time, we can come back and look at this. But otherwise, now that you remember this, right? Configuration information and state. So we're going to look at everything is a widget, stateless or stateful. Stateless widgets are things in your mind. You have to think that if it's a class, every time I stamp it, it's going to look exactly the same. No two instances are going to look different. Images, text, etc., right? You stamp them out, they're always going to look the same. Stateful widgets, on the other hand, every time you stamp out or instantiate that class, it's going to have state reflecting something that's there. Buttons. Is it on or off? Some buttons could be clicked, some couldn't, right? Counters. So anything that has state. Now here comes the difficulty, right? And this is the one that's the hardest to wrap your mind around. Maybe this will help. Stateless widgets, I told you, have build methods. Stateful widgets have a create state. This is what the widget lifecycle looks like. All these widgets have this thing called a build context that maintains some information about the container and how it's being put in the hierarchy, right? Stateless can be built in many contexts because you're stamping it out, no difference. This one gets new state for each one. If you understand this diagram, you will have understood the difference. It's this. If you're familiar with React, this will actually look kind of intuitive. Remember I said configuration and internal state? Configuration data is stuff passed you from the parent down, right? So parent, and even stateless widgets can have configuration state. Parent gives it to you at the time you're stamped out, just like in React props, right? Stamped out, you're getting it, you're instantiated. That's also state, but it's what you're initialized with, right? And then there is reactive internal state, which is what happens when you have things that are being clicked or changed in yours, right? either of those changes, either your parent gave you new stuff or something in your internal state changes, that triggers the refresh. Simple as that. Very reactive, very React-like. Does that make sense? So now comes the hard part, and I don't think I'll be able to kind of explain it completely, but I'll try, and after that we'll wrap up. If you look at the code, and it's like 45 minutes. Do we have time to look at code, or do you want, if anyone's interested, you can come. You do. I think you're in the minority. I will tell you one thing and then let it go. If you look at the code, the big difference, think in your mind, a stateful widget will have stateless, like that state object that encapsulates the state of that widget, and it'll have all stateless widgets under it, right? So the way you architect, and this is what you got to wrap your mind around, that you always try to take anything that's stateful and split it up into a stateless widget and a state object. So that anytime state changes happen, you can throw the view away, instantiate a new one and refresh it, but your state, the object containing your state persists. And that way you're minimizing the number of things you need to re-render, right? So it's really, really performant in what you have to do. Does that make sense? And that's the only thing, like that's the hardest thing you're going to have to do with Flutter next, is figure out how do you architect your apps. We won't be able to get to look at that, so we'll see. I'll leave you with one advanced topic. All this is great, everything you're saying, hey, they're going to give me widgets, I'll just compose my app from the widgets, I'll figure out whether it's stateful or stateless, put it together, I'm all done. What if they didn't build the widget for things I wanted? What if there's native code, an API that they're an alpha, they don't support it yet? Or what if I've written Android code that I want to be able to invoke while I'm doing the transition? Remember I told there's a place where you might be able to evolve? You can do this with this capability called platform channels. And effectively, it's a message passing paradigm. Think like intents. Your Flutter app can send messages over into the native domain, have it do something, get the data back, and then fix it. So this is where, if you're an open source person, if you're a community contributor, huge impact. Anything you build right now, you'll get a good shot of having it seen and used by a lot of people. So anyway, we're almost done. Let's recap. Hopefully what you saw today, effective tooling, good IDE, command line tools, hot reload, rich widgets, easier to develop, Dart lang if you can swallow it, that's the only thing. Everything's a widget. Reactive rebuilds will happen based on configuration changes or initial state change from within the widget itself. And your value proposition is you build in Dart one source. It gets compiled for you into Android and iOS and any other platform like Fuchsia down the line. And because everything is extensible, even that widget code, the open source ones, you can go in and customize them. So you could actually come up with your version of Cupertino View that kind of fuses the best of both. Or you could come up with Windy City widgets, right? That could be something that's... And I'll leave you with the final thing. This is, for those who are familiar with it, Blind Man and the Elephant, right? I love this kind of the moral of the story, right? We all kind of tend to see things from the perspective of things we're familiar with, and sometimes we miss the big picture. So the only thing I'll say is, like, you might fall into one of these brackets. Go look at it and try to understand the other stuff, and you might find that there are interesting things in there that will make you want to explore this further. Next steps, 2 guided tutorials. Very, very easy to do. Takes less than 2 hours to get it done. One is building UIs with Flutter that walks you through how you would actually build one of these apps, tells you about the widgets, architecture, everything. Second is, this is only front end. You still need a back end. Firebase with Flutter is a marriage made in heaven, seamless, so you can try those out. There are also these additional code labs in the Dart space if you kind of want to get really familiar with Dart. The intro to Dart for Java developers is so ridiculously easy. I did it like in 5 minutes in transit. And this is attribution. The slides are available there, so you're more than welcome to grab them. And I think I kind of went a little over, but thank you very much. If you have questions, I'll be hanging around. More than happy to answer them.